Welcome to Hidden Layers, where we explore the people and technology behind artificial intelligence. I'm your host, Ron Green. We're back with another Decoded episode, where we cover the most important recent developments in artificial intelligence. Today, we're discussing news from Meta, OpenAI, Microsoft, and some surprising Nobel Prize awards. To help me cover everything, I'm joined by two of my amazing KUNGFU.AI colleagues, our Chief Scientist, Dr. Steve Kramer, and our VP of Engineering, Michael Wharton. Michael, Steve, so glad to have you both here today.
Cool. Glad to be here. Yeah, great to be back.
All right, I'll kick off this Decoded episode with some more OpenAI drama. There's been a lot of stuff that has happened really in the last year, calendar year. They've, number one, dissolved the safety team, the alignment team. All the leadership from that organization or that part of the organization has moved on. They're at Anthropic and other places. All but two of the original co-founders have left the company with the departures this summer. And now it's just down to Sam Altman and Greg Brockman, who is actually himself on leave until the end of the year. So we'll see if he's coming back. And then they are switching to becoming a for-profit and poised to give Sam Altman a lot of equity. So I want to kind of tee up a case about their future, because in addition to the drama, there's a bunch of other stuff that's kind of happened recently that I think sort of diminishes the long-term likelihood that, they will be successful. But then there are some hedges against that I want to cover as well. So a couple things. One is they're burning through cash. OpenAI is expected to lose between $4 and $5 billion this year. Now, that's not as big a deal as it may seem for some companies, because they've managed to raise just recently another, I think it was six. What was it?
Close to six.
Around six at a valuation well over $100 billion. I think it was over $150 billion, maybe even. They've also burned up a lot of goodwill in the AI community, right? They are definitely, I would say, viewed with increasing skepticism by most AI professionals. They burned up a bunch of hype around the coming GPT-5 with the release of 0.1 and 4.0, right? And so you put that together, and one of the questions I have for you guys is, with all of these major departures, including Ilya Sutskever, one of the co-founders, and I think one of the most important people in artificial intelligence right now, would those people really be leaving if GPT-5, sort of a major next step, was really on the horizon for this year, even next? And so I kind of I've got more I want to cover here, but I want to ask each of you, what do you think about OpenAI's future? Are you bullish on them? Are you bearish?
I'm bearish. What about
you? Same here. It seems like, there's just been so many concerns about the, obviously all the leadership turnover. That's a major, that's a major sign. If things are going well, you don't have co-founders leaving, and especially I think there were definitely some reports of like whistleblower concerns around product, new models like 0.1, being sort of rushed out with, sort of, less than optimal safety kind of measures.
Right.
So those are big concerns. And that's beyond just, we'll talk about more later, just the massive amounts of cash as well as data and power to build these ever larger models.
Yeah, I think Sam did a really good job of just capturing a bunch of FOMO that I'm sure a lot of investors were experiencing at that time. But the big thing I keep coming back to is that I feel like they're not necessarily differentiated, or I'm sure we'll talk a little bit more about that, but in terms of their current IP, what they have in-house, it doesn't feel like they're differentiated. Their service isn't really sticky. It's an API that's like a one-for-one swap with a standard spec now that you can get with anyone else.
So true.
And they're kind of banking on future innovation rather than innovation that's already happened.
Yeah.
You're like betting on a technology that's supposed to create these amazing technologies.
Right.
It's fun to think, oh, this is the last investment you'll ever make because, this thing's going to have scientific discoveries that's spitting out all this amazing stuff. But you're betting on something that doesn't exist yet, which is risky.
Right. All right. So I'm going to make both cases. I'm going to make sort of the the bear case and the bull case for OpenAI right now. So I think on the bear side, it's everything you said. They've really lost a lot of their differentiation. The fact that Zuckerberg and Meta are releasing these really powerful large language models and making them open source has taken a huge amount of wind out of their sail, and it's really had a big effect. Another issue is the fact that models are increasingly getting smaller and easier to run and deploy on your own, right? And the interchangeable aspects of the APIs and all that other type of stuff. And so there's less and less differentiation. And even though I do think Strawberry has demonstrated some fairly impressive reasoning capabilities, it's not that differentiated. And it's certainly nothing that the other big players won't be able to replicate. Okay, on the flip side, I think there are a couple things that may make this actually work out for investors. One is they've got great strategic partnerships, right? They've got this massive advantage with access to compute from Microsoft. And I think that gives them sort of an unparalleled capacity in the cloud that most of the other competitors will struggle to catch up with. But it's also becoming, less important. They've also got really great brand dominance. Everybody thinks of ChatGPT when they think of AI, right? It's almost synonymous. A lot of people, especially non-professionals, will just say ChatGPT when they mean any AI. And then this is the thing that I think maybe a lot of people are overlooking. But take this with a grain of salt. But Sam is out there trying to raise, at one point, trillions. Now it's just several hundreds of billions to build power and have some of the largest leading chip makers in the world establish global fab networks, because there's sort of this OpenAI bet that compute is going to be the bottleneck for growth, and they don't think that there's going to be enough supply, and so they want to put a bunch of investment in that direction. So I think, to summarize, I share your skepticism. I think that that's a lot of money, but all it will take is one or two major breakthroughs, and maybe they'll be back on track. So we'll see.
Yeah. Well, it's interesting, even to the point about the Microsoft relationship, which is interesting. Obviously, it's a very strong partnership. But even my understanding, even Microsoft itself is also looking into competitive models. So, because it's finding that just to run the OpenAI big models is just way too expensive.
Well, I
think that's just like an underlying economic reality, not just OpenAI's, but literally any big model.
That's right. That's right.
Just the business case.
I heard through the grapevine firsthand recently that Microsoft is actually also a little frustrated with OpenAI. They're going head to head increasingly on potential customer deals, and Microsoft's not happy about that. So we'll see how that plays out.
Yeah.
All right, Michael, I'm going to throw it to you. What do you have?
Well, it's very, very related to the topic we were just talking about. I might have already shown my hand about what I think here. But there's this really interesting paper that one of our advisors, Paco Nathan, shared with us. And it's called Hype, Sustainability, and the Price of the Bigger is Better Paradigm in AI. And there are 3 authors on it. One of the co-authors is actually one of the original founders of the public release of scikit-learn. So someone really well known in the open source community. These are people whose opinions matter here. But there are 2 claims that this paper is trying to refute that seem to be really pervasive in industry right now. One of them is that improved performance is a product of increased scale. Now, they're not necessarily saying that you can't get performance from scaling. We all know that to be true. They're just saying that that's not the only way. And another claim that they're trying to refute is that all interesting problems addressed by AI require these large-scale models. It's not necessarily a requirement that you have a giant model. And even further, having a giant model that you use to solve a narrow task, you're wasting tons of money. Like if you've got a giant GPT-4 that's really good at inventing new recipes and like complex reasoning and all these other things, but at the end of the day you're trying to just make sense of tax forms,
right?
You're throwing a lot of money down the drain because you don't have a hyper tailored model.
Right. And not only the training costs would be really high, but the inference costs would be really high.
Yeah, the inference cost is huge.
Right.
And I think a lot of people are already finding that out, that it's not necessarily economically viable to have these large models doing these impressive tasks when, you know, we keep seeing this pressure for these smaller and smaller models.
Right.
So I think, you know, the one thing I don't necessarily agree with that this paper says is that I think they're trying to make the case philosophically that we should avoid it for reasons of sustainability and, you know, the carbon footprint of these models are insane. But, you know, historically in our field, these sort of ethical arguments don't go anywhere.
I know.
Like, y'all remember that petition to make the pause on the development that happened a while ago? Went nowhere. If anything, it fueled the fire and accelerated things.
I actually agree with that.
Yeah. Well, I think those ones are actually quite different. I think that whole AI pause one was kind of from the AI, just this, we talked before, there's this vast divide in terms of like, it's like everything into like doomsday machine, kind of thing. So it's, I think it's a little bit different. I think this is a really nice wake up call to like understand. Sure, there are some problems that probably you would need very large models to be able to account for the complexities, but it's probably like, just don't assume that's the only thing you care about, especially given, as we know, that we're already running into massive power challenges where like even like I think the training costs of like entire states could not so they're having to revive nuclear power plants to
right. Well, and this whole topic intersects with one of my sort of passion points right now, which is not everything needs to be generative AI, right?
Right.
There are, I would argue right now that the bulk of the opportunity to deploy AI within almost any business domain is centered around domain-specific AI, right? Narrow AI that is solving a specific problem. To your point, you don't need a large language model with these incredibly broad capabilities and really expensive to train and really expensive to run in inference mode, when if you focus on solving a specific problem, you can achieve that not only more cheaply, but much, much, much more accurately, generally speaking. So I'm a big fan of this. The one thing that I will say about the scale that's interesting is, you know, I don't want to talk out of both sides of my mouth, but I'm super interested to see how big these models get before we start seeing tapering off. I think there's a general consensus out there that we have a couple of orders of magnitude still before we'll see decreasing returns on that investment. But I don't know. I would love to have that from a sort of a scientific perspective. I would love to see
where you see
what the answer is.
Off. Right.
Yeah, where are we going to start tapering off on that curve?
Yeah, there are prompts we could ask that people would pay billions and billions of dollars to get the answer for, and just one prompt, like, you know, solving world hunger,
right?
Whatever the heck.
Yeah.
The Riemann hypothesis.
The Riemann hypothesis is the perfect example. Yeah, 100%.
So we'll see.
We'll see. All right. Steve, what do you got for us?
Well, last month I got to go to the AI conference in San Francisco, which was really awesome. So Ben Lorica was the host of that, and our friend and advisor Paco was one of the MCs. So it was really great to get to spend time with him out there and the team. So lots of really good sessions over 2 days. I think when I had distilled down the key takeaways, one was, first of all, that absolutely no one is using LLMs by themselves in enterprise AI use cases in production.
And just really quickly, you mean not they would use them, but they wouldn't they wouldn't take the output.
Absolutely.
As
like
raw.
People who might have tried failed badly.
Right.
And so basically, like everyone, like the biggest sort of like topic that came out of that part, well, two of them. First was GraphRAG, so graph retrieval, augmented generation, because RAG itself is a little bit of, a lot of folks is like a little bit kind of a Band-Aid, or really
totally
going to slap something on to try to minimize the deficiencies of LLM hallucinations. So GraphRAG, especially building it, sort of integrating the output of LLMs with knowledge graphs, you know, allows you to have a much more sort of vetted source of knowledge. And as we know before too, that even if you have a large model, it is really difficult to inject new knowledge into the LLMs. And so by doing this sort of like compound AI systems, so very much, and that was kind of the along the lines of compound AI systems, many companies talked about using sort of these agentic AI workflows, many of which might not even use generative models, but are using small. You might just use a decision tree or something, something traditional.
Yeah, and the idea is
small.
Right. This agentic approach is you would have different capabilities that maybe the main model could call out for to address certain tasks.
Right, exactly. And then along, sort of similar to that, so the compound AI systems, I think the third major bucket was just a surprising, at least to me, amount of work both on the research side as well as tools and frameworks for basically assurance around AI systems. There's a company called Fiddler.ai that had a lot of really interesting capabilities around sort of not only model reproducibility, but even assurance, like having cryptographic, hashing and coding of all the model assets, the model weights, to make sure that the model has not been tampered with. And because there are a lot of cases where, depending on how the model is deployed, you could have adversarial attacks. And so you want to be able to really have assurance. And interesting, there was also a lot of discussion both from a policy perspective around ethical and responsible AI, but also especially with a lot of international companies who were there, obviously with the stringent requirements around the EU AI Act. And so there are just a lot of, from a compliance perspective. And so some companies are actually coming out with both process as well as tool-based approach to help with compliance with those kinds of things. So I would say those really top things were GraphRAG, agentic AI, and a lot around sort of AI governance and compliance.
People are starting to take AI governance seriously.
Oh, very much.
It's
so.
like year 2024. It finally became
It's
finally became a real thing.
We did get a really good. But at that point, it was still an early preview of Llama 3.2. So
Oh, that's nice. Okay, well, I know that's on your plate. Let's just switch to 3.2 right now.
All right, let's do it. Yeah, so I think this is a pretty monumental release. We've talked about Llama 3.1 on this podcast before. Llama 3.2 is an extension of that model, but it's multimodal.
Right.
So what they did was they used a vision encoder, and they have a projector that allows you to take vision inputs interleaved with your text inputs, stick them in the same input layer of that model, and then you get a multimodal model at the end of that. And the cool thing about it is, it's totally open source. You mentioned the EU AI Act. Something that's interesting is this is not available in the EU.
Right.
And that's because there are concerns around copyright. They don't know exactly what to expect there. And they can't necessarily prove that this model wasn't trained on copyrighted material in the EU. So
that's intriguing. See, it's still the Wild West here in the States.
Yeah, we're just, it's total Wild West. But they're a little bit more buttoned up and taking it seriously, I guess. But, it's competitive with other models in its class. Okay. If you go to the LLMs arena, where again, what they're doing there is measuring human preference.
Right.
So I'm not sure if y'all have played around with it, but you provide a prompt, and then it gives you.
Have you played around with it much?
Yeah, it's a great kind of intuitive idea. I think what they do is they behind the scenes have a blind random selection of 2 LLMs for a particular prompt that you provide, and when you get your response, you choose your preference on which one you think's better, and then if you do that at scale with a lot of people using these models, it'll allow you to stack rank them globally and figure out which ones do humans prefer regardless of the benchmarks.
Oh, I love it.
So Llama 3.2 in the multimodal arena is number 12. And other than Quinn, I think it's the highest, at least from the States, it's the highest multimodal open source model. All the others are like Claude, like the Haiku model and all the other stuff you'd expect.
Yeah.
But personally, I don't really pay much attention to these benchmarks. Sometimes people can game them. Everyone's model's state of the art. There's no substitute for actually just sitting there and playing with it. So a couple things I usually do, like, there's a startup we work with that processes architecture documents. So I tried that. I tried throwing in a page and just asking questions like, what's the dimension of this room? How many square feet is it?
And you put in like a blueprint?
Yeah, just a little architecture drawing that I found on the internet. And it nailed all of it.
Oh, really?
It could do things like summarize all the rooms on the floor plan, list them out, count them, and tell you the square footage of each.
Whoa.
And it is, I've tried the same task with other models. I've tried it with like Lava when that was, big on the scene. Florence, I think, was another one, maybe like back in the day.
Yep.
every time there's a new model like this, I catch myself trying this, and it's the first time I'm like, wow, okay, this is great. Oh, this is amazing.
That is really impressive. And I guess it just must have seen that type of data in its training data set at least a little bit.
Yeah, I'm sure.
Wow.
So it's really great. And I think time will tell how we're going to use this.
Yeah.
You know, one of our engineers, Nathan Mundy, he wrote this blog post about how LLMs are sort of engines for cars. Rather, we tend to look at them like vehicles. But I think that tracks with your experience at the AI conference, that these things are components of larger systems. Right. So I think it's just, we're going to have to see what people do with these things. It's a powerful engine that's going to power, I don't know, it's enabling a lot of great research and development. So thanks, Zuckerberg.
Yeah, I know. I can't believe I'm going to say this again, but thanks, Zuckerberg. This is really, really great. I think it's critical to keeping things open.
Yeah, absolutely. Well, and one of the interesting note about the Llama 3.2 is the license change they made so that to allow for downstream use, you can use it to fine tune. You can use one of the big models to fine tune a smaller model for commercial use. Now there are a few caveats. Apparently, you have to like name your model.
That's what I was going to say. Right?
Llama,
it has to have the llama. In
so
the
it's
name
give
somehow.
a little attribution. So it's not like completely free. So and plus, I think there is still a scale limit if you have more than it's 500 million monthly users.
That'd be a good problem to have.
It'd be a good problem to have. In which case, you have to obviously negotiate with Meta. But I thought there was a very interesting change on the licensing side.
Yeah, for the better. All right, I've got a really interesting paper I want to talk about here, and the name of it is "Intelligence at the Edge of Chaos." And I'm doubly excited about this because Steve, you did your PhD in physics, looking at dynamical systems, nonlinear system, chaotic systems. So this paper is really ambitious because they're trying to see if they can understand in a deep way how intelligence emerges. So what they did was they used cellular automata. And just in case somebody's listening to this and they don't know what that is, they use what are called ECAs, elementary cellular automatas, very basic. They're two-dimensional grids. Each, you can think of almost like a chessboard, and each square, it has a binary state. It's either off or it's on. And you start with some random state, and there are rules based upon the states next to you to how you change your state, whether you would turn off or on.
It's like the game of life, right?
It's like Game of Life. Like Conway's Game of Life is probably the most well-known example of that. These were really hot in the 80s and 90s because they could be used to study complex systems. They originated with von Neumann in the 40s.
Oh yeah,
right. And but it's great because they have this emergent chaotic behavior. You can have these really simple rules associated with these two-state cellular automata, and after just a little bit of time, it's unpredictable, right? You get this emergent chaotic behavior. So this is what they did. They wanted to see if models that were trained on a range of cellular automata, ranging from sort of very basic, very predictable, all the way up to chaotic, just completely unpredictable, and everything in between, if there was a shift in the intelligence, capabilities of those models on downstream tasks, okay? And what's amazing is it actually looks like there is. The models that were trained on these simple CAs that were very predictable really did not perform very well at all on downstream tasks. The ones that were trained on sort of chaotic systems where it's hard to really pick up on anything in a deep way because it's so deeply unpredictable, they did not perform as well either. And the ones that performed best in the middle, where it wasn't too simple, too chaotic, the ones that performed best were right up at the edge of chaos. So where there was still, some predictability there, but your ability to learn and predict these next outcomes was right at the edge. So you're sort of forcing the model to really pay attention and learn complex patterns. A couple of things here that I think are amazing. They tested the model downstream on a bunch of things. Francois Chalet's ARC, predicting the next chess move. And I can't remember a couple of other sort of, legitimately challenging tasks. And their takeaway, which I've got right here, which I just love, is they say that this suggests that intelligence and artificial intelligence systems can be developed through exposure to complexity rather than requiring inherently intelligent data solutions. And that in particular, that intelligence is fostered in systems that operate at the, quote, edge of chaos, where there's a balance between structure and unpredictability. So I love this. Love this paper. Amazing. So Steve, what are your thoughts on this? I mean, you worked deeply in this.
Yeah, well, and it's so cool to see, first of all, as you mentioned, even von Neumann, a lot of these sort of fundamental ideas just reemerge in different fields over time and time again. That's what I love about AI now. It's so interdisciplinary. So that's, first of all, that just, it warms my heart to just like, oh my God, coming out, like even in the paper, they talk about Krylov exponents and Lyapunov exponents. Like, yes, I'm all over that. But anyways, it is interesting because I actually did my PhD within complex systems on nonlinear models of rivers and river networks. And this is like way back early 90s. And so it was a $40,000 silicon graphics machine that was 40 megahertz.
Yeah, megahertz
processor. So like I was able to like solve, basically show stability problem, doing fully solving nonlinear partial differential equations. But that was just one-dimensional or two-dimensional river channel, so stability there. Yeah. And so I thought, well, I have to like see how this carries over. And so I actually created basically discretized models that sort of correspond to 2D cellular automata. Yeah. And then even with very straightforward, very simple rules, it was able to basically letting random rain fall on a landscape that could be eroded, then you get river networks that generate, and the river networks actually match the exponents of real rivers in the world. And so I very much see it's like, yes, it's absolutely that a lot of the, as long as you have enough of the fundamental underlying dynamics, and it just makes me think like, what's the biological analogy to those ECAs? Like, are you going to look at neurons and interconnections, that kind of thing?
Right.
But anyway, the other thing I'm very curious to think about too, that makes me think about, is the whole idea of manifold learning. Is like you're trying to think of like what's the underlying state space that represents the system you're trying to model, and is the representation you're trying to do. So a lot of times we talk about dimensional reality reduction, and so can we find some way of, a complex enough, set of rules in this case to represent the underlying reality of the downstream model, a system that you're trying to model.
Yeah, and I think that's exactly what was happening here, right? Is there were these explicit rules that the CAs were following in the model, which was, by the way, was a GP2 model that they used. A little bit of a different sort of tokenization input-output without softmax for a bunch of reasons. But it was essentially having to learn this latent, sort of manifold space that represented those rules. And the more complex those rules were, the better that whatever that manifold looked like, the better it was positioned for downstream tasks. And what they would do, this is the last thing I'll say about the training, is very clever. They would freeze the bulk of the network, but let the input and output layers be learned. So that's how they could essentially assess whether the different CAs and what the model learned there was allowing it to essentially be pre-trained for more complex downstream tasks in that emergent intelligence.
It's very interesting.
Yeah, that's really clever. That reminds me, there was a speaker that I think you brought in for EPDS or Friday research sessions. I'm blanking on who they were, but I remember their research was basically what they would do is they would take these attractors, these equations of motions, generate time series signals that weren't necessarily relevant to the domain of interest, but then they would use that to augment time series data, and saw that it was improving the performance of their baseline models.
Yeah,
Do you remember who that was? I'm totally blanking.
Yeah, I can't remember his name right. A physics professor, actually. So yeah, I'll dig it up. We'll put it in the show notes because it's really fascinating. Once again, just this overlap among the fields.
I know we're zeroing in slowly on what is behind intelligence.
Yeah.
All right. Okay, Steve, what do you have for us next?
Well, as we've all talked about, like on our Friday lab days, that there are so many AI research papers that come out every day. Plus, with all the interest and hype in AI, there's just a huge amount of noise online, and so it's impossible to keep track of, and also to know what to focus on. So, as kind of like a side IRAD project that I've been working on this year is actually I basically put together a vetted list. I think it's around 180 known AI experts and influencers who are active on X/Twitter. I still call it Twitter, so I'll say tweet.
Me
so
too.
Just
me too.
Folks who listen, I know it's X now, but I'll say Twitter. And then basically, I was able to use the Twitter AI to look download the recent tweets by all of those accounts. I did that several times. I did it back in July and then in September and October. So now I think I've got roughly 400,000 tweets by those AI experts. Oh, and interesting, actually, after the first time I did it, I had that seed list of experts. And then I do something in network graph analysis called the K-chord decomposition. So I always like to describe that as like peeling away the layers of an onion. So the outermost layer, that's cornice 1, you take that off, the nodes that have degree 1, then you delete those dangling edges, and you work your way in. So that what allows you to do is to find the most influential people, research papers, or nodes within the network, whatever they represent. And then I did that once, found the people at the center of the network. Lo and behold, there were a whole other set of folks who were in this network. And so basically I added those to my initial list. And then every time I looked for tweets after that, I looked at the expanded group. So that's how I got, now this on the order of 400,000. And then what I did was folks at the center of the network, I extracted all the links, the embedded URLs within the tweets, and a lot of the links go just within Twitter or X, but then a lot of them, point outside as well. And so from a research perspective, the main 3 ones that are of interest to us and our team would be archive.org, which is where research papers, preprints are posted. YouTube videos, of course, some can be like cat videos or music, but a lot of people do post actual conference videos or descriptions of research. And then also GitHub repos, so software, code repositories. And so basically then I extracted all of that information to figure out like what are all those research papers, code repos, and YouTube videos that those experts are linking to. And so that way we can really use that to focus our attention on not everything that's being published, but only things that are being shared and discussed by vetted AI experts and influencers. And so the cool thing is, it's part of that, using sort of traditional network graph analysis techniques, I was also able to kick the tires on some of these new LLMs. Like I tried the Llama 3.1 $8 billion parameter model, as well as I think it was Llama 2B. I think, Michael, you kindly pointed me to that. And then actually did topic detection. Oh, okay. Basically asked a model, what is this paper about? And it would come up, both the models would come up with some very interesting sort of fine-grained descriptions like, hey, these are the key topics. Like, wow, that's really cool. But in practice, what I found, there were so many of those. They were like on the orders of probably 10,000 topics, very fine-grained topics. I think, well, I need a higher level hierarchy to understand. So there's a great website called Papers with Code that I know we track all the time. It has papers, but it also has methods and data sets. And basically I said, I think there are like 17 or 18 sort of top level ML categories. And so initially I tried to get the LM to say, showed a paper, which of these categories is this about? And they would just absolutely hallucinate and not.
They wouldn't obey. Were they picking different categories?
They would make up stuff outside that list. I would ask so nicely.
LLMs.
Yeah. I asked so nicely, please reply only with one of these from this list. And I said, nope, we wouldn't do it. So finally, I just gave up and I went back. And I think I shared this with you earlier that on Hugging Face, which of course we highly recommend, is just an awesome resource to play around these models. There's an example of a zero-shot text classification model based on BART, which is a different later variant of BERT, but and it did great. It was way faster, obviously, and this is all free though, just running on my laptop using Llama. So anyway, so I'm super excited about that. So the plan is we'll be working on a blog post about that. I plan to post, a lot of the maybe whatever the kind of the top 10 takeaways, the papers and so forth on. We have a great partnership with data.world, so I want to post that stuff there. And so anyway, if you're interested, we'll put it in the show notes if you want to find out more about that, we can get you hooked up with that. So I'm super excited.
When are you going to have the all the processing done?
Oh gosh, I hope a first version, maybe in the next 2 or 3 weeks.
Okay,
depending on we have a bunch of exciting projects coming up here at KUNGFU.
Yes, we do.
It's always a matter of juggling.
Yeah, it is definitely busy season. That's great, Steve. Thank you. All right, I've got one more thing I want to kind of finish with today, just because I'm so happy about this. So we had 3 different people, really well known within the AI world, win Nobel Prizes last week, and this just makes me irrationally happy. So Jeff Hinton and John Hopfield. Jeff is 76. John is 91. I mean, just amazing contributors. Both won Nobel Prizes for their contributions to the foundations of artificial intelligence, but they won the physics award, right? There isn't an AI award, Nobel Prize, and neither is there a computer science or a mathematical award, right? Hinton, one of the godfathers of deep learning, unbelievable contributions. He was one of the co-developers of the backpropagation algorithm, probably the single most important development in the history of artificial intelligence. Hopfield, unbelievably important. He created what's called the Hopfield network, which showcased how neural networks could store and retrieve information back in the early 80s. I remember learning about this in undergrad. Just I'm unbelievably happy about that. And then completely independently, we had David Baker, John Jumper, and Demis win the Nobel Prize in chemistry for their work on predicting and creating proteins using AI. And of course, Demis is one of the co-founders of DeepMind, the folks behind AlphaFold, which really was the first giant leap forward in protein fold prediction. And this is, for those who don't know, this is a sort of a quote 50-year-old dream that you could take amino acids and just from the sequence of amino acids be able to predict what type of protein it would fold into. And proteins are unbelievably important to our biology. So I'm really, really happy about this. But I know some people are maybe on the fence about people working in AI, ostensibly maybe sort of a computer science mathematical field winning a physics award or winning a chemistry award. I personally feel that this is a real strong indicator of the future direction of science. We are going to have AI-assisted science, research, and discovery going forward. But that's just me. What do you two think?
And if you're making the old guard frustrated, that's probably a good sign that you're pushing boundaries.
That's a good point. Yeah.
Yeah, I think it's great, and it's undeniable the impact both of those have made. I think the protein folding is the most immediately. You can tell really quickly where the value's being driven. I mean, it's amazing to be able to predict protein folding and has impacts in medicine and all sorts of other things. I think that leap is a little bit farther to make when you go from backpropagation, all the other stuff we experience today.
Right.
But that's the thing with foundational science. You know, you're creating a very, very broad foundation that spawns all sorts of innovation.
I couldn't agree more.
It's like the top most hot thing that's going on in the world right now on planet Earth.
That's right.
They totally deserve it.
Right. Which is why to me, it's like, it makes a lot of sense. AI is super interdisciplinary. We've seen it across,
yes,
just so many different fields, and obviously, especially hot field. I mean, that's like core. I mean, they're very. I think. It's been a while since, because I was basically, back then undergrad and grad school, hot field networks. Some very close ties to statistical mechanics and phase transitions, and all this stuff is very much physics. It's just, So I'm also very pleased by
it's so great, because if you'd have told me we'd be discussing in 2024 cellular automata and hot field networks and all this other sort of stuff, chaos theory, it's all coming back again. It's just cyclical.
Mm-hmm. What's crazy is I was thinking about this term the other day. Like we've experienced all these AI winters, and I was like, I feel like this season analogy, we're not in a winter anymore. It's more like a spring. Apparently that's a term. Like there's a Wikipedia page for it. You can check it out. Yeah. Huh. And I think that's a really good descriptor of the thing we're experiencing now. Like all those trials and tribulations and failures that have happened over decades and decades paved the way for us to experience this wave of growth. And it's amazing.
That's right. In the history books, they'll look back at it and they'll go, oh, backpropagation was invented in 86. And then the AI revolution happened just shortly thereafter, right? It'll seem like a blip in the history books, right? I love it. All right, guys. Well, thank you so much today. I really enjoyed this as usual.
Yeah, this is great. Thanks for having us.
Yeah.
Thank you for listening to Hidden Layers. This series is hosted by KUNGFU.AI, a management consulting and engineering firm focused exclusively on artificial intelligence. If you have any questions or thoughts about today's episode, or if you know someone we should feature, please visit us at KUNGFU.AI.